Welcome to Cosmic Compass, the channel where together we journey through the cosmos to uncover the stories of worlds beyond Earth. From frozen moons to distant stars, we explore the science, the mysteries, and the possibilities of life in the universe. Today, let's turn our focus to one of the most fascinating moons in the solar system, Europa, a frozen world of ice fractures and hidden oceans. Could this be the place where we finally find life beyond Earth? Let's find out. What if one of Jupiter's frozen moons hides more water than all of Earth's oceans combined? And what if beneath its icy crust something is alive? This is Europa, a world that has fascinated scientists for decades. Ever since the Pioneer probe captured the first close-up image in 1973, followed by Voyager and Galileo, Europa has surprised us again and again. It is a place of fractures, chaos, and hidden depths, where surface mysteries hint at a vast ocean below. We still have many puzzles left unsolved, but piece by piece we are beginning to understand this extraordinary moon. In this video, let's explore Europa's secrets together, its orbit, its strange surface, its tenuous atmosphere, and the tantalizing possibility that it could harbor life. I'm Alex McColgan, and you're watching Cosmic Compass. Let's begin our journey into the frozen world of Europa. Europa is one of the 4 Galilean moons discovered by Galileo in 1610. It is the second closest to Jupiter and the smallest of the 4, yet it is still the 6th largest moon in the solar system, just behind our own moon. With a diameter of about 3,100 kilometers, Europa is comparable in size to Earth's satellite, though far more mysterious. It takes Europa just 3.5 days to orbit Jupiter, locked in a synchronized dance with its neighbors. In fact, Io, Europa, and Ganymede are trapped in a 4-2-1 orbital resonance. Every time Ganymede orbits Jupiter once, Europa orbits twice, and Io 4 times. This delicate resonance is not just a curiosity, it has profound consequences. The constant gravitational tugging prevents Europa's orbit from becoming perfectly circular. Instead, it remains slightly elliptical. As a result, Europa is continually stretched and squeezed by Jupiter's immense gravity. This tidal flexing generates internal heat, cracks the icy crust, and shapes the very landscape. Without it, Europa might be a dead frozen ball. With it, Europa becomes an active, dynamic world. So already from its orbit alone, Europa stands out as a moon worth our attention. Europa's surface is striking and unlike anything else in the solar system. Made predominantly of water ice, it gleams with one of the highest reflectivities of any celestial body. Europa reflects about 64% of the sunlight that hits it, making it 5 times brighter than our moon, but brightness is not its most remarkable feature. Across its surface stretch long continuous fractures and cracks called lineae, Latin for lines. These dark streaks can run for thousands of kilometers, though many are only a couple of kilometers wide. Scientists believe they form as Europa's icy crust is pulled apart by tidal flexing, with warmer material rising from below to fill the gaps. They resemble mid-ocean ridges here on Earth. Alongside the lineae are dark spots known as lenticulae, typically around 10 kilometers across. These are thought to result from pockets of warmer, buoyant ice or water pushing upward, sometimes breaking through. In some cases, the surface collapses into strange, jumbled landscapes called chaos terrain, patches of broken ice blocks surrounded by smoother plains. These chaotic regions may hold vital clues to what lies beneath. Another peculiar feature are icy spikes or penitentes, possibly towering 15 meters high along Europa's equator. Formed by direct sunlight sublimating the ice, they resemble structures we find in Earth's high-altitude deserts, but on a far grander scale. Surprisingly, Europa is almost devoid of craters. Fewer than 50 major craters scar its face compared with thousands on Earth's moon. This tells us Europa's surface is geologically young, only about 30 to 180 million years old, remarkably fresh on the timescale of the solar system. Taken together, Europa's surface is a puzzle. It is smooth yet fractured, ancient yet young, and shaped by forces both internal and external. And while beautiful, it is also deadly. Europa orbits deep within Jupiter's radiation belts. Its surface receives a daily dose of about 5,400 millisieverts of radiation, enough to kill an unprotected human in a single day. Even the reddish-brown stains that mark Europa's cracks are products of radiation created as salts and sulfur compounds mix with the ice and are altered by Jupiter's powerful magnetic field. Europa's skin tells a story of stress renewal and survival, a frozen world that is constantly reshaping itself. Radiation not only scars Europa's surface, it may also cause it to glow. Laboratory experiments suggest that energetic particles striking the ice release visible light, meaning Europa could shine faintly on its dark side. From Earth, we can never see this, since Europa's night side always faces away from us, but future missions may one day confirm the effect. Radiation also helps to create Europa's tenuous atmosphere composed mainly of oxygen. Unlike Earth, this oxygen is not produced by plants, but by radiolysis. High-energy radiation bombards water ice, splitting it into hydrogen and oxygen. The lighter hydrogen escapes into space, while heavier oxygen lingers. Together, escaping molecules form a diffuse cloud that trails Europa along its orbit around Jupiter. Though this atmosphere is incredibly thin, almost a vacuum by Earth's standards, it is another clue to Europa's active processes. Then in 2012, the Hubble Space Telescope detected something extraordinary: plumes of water vapour erupting from Europa's south pole, reaching up to 200 kilometres high. In 2018, scientists re-examined old Galileo data with new techniques and found supporting evidence. These plumes are critical. If they truly connect to the subsurface ocean, then spacecraft can sample Europa's hidden waters without ever landing or drilling through the ice. Imagine a passing probe could taste the chemistry of an alien ocean just by flying through a plume. With every new observation, Europa grows stranger and more compelling. We see ice that glows, an atmosphere born of radiation, and plumes that whisper of a deep ocean below. Let's now turn to that ocean, the most intriguing mystery of all. Beneath Europa's crust lies perhaps its greatest secret, a global ocean. Hints of this hidden sea came first from the Voyager probes, then more clearly from Galileo in the 1990s. Scientists noticed that Europa's magnetic field shifted dramatically between measurements. The only way to explain this was with an electrically conductive layer beneath the ice, most likely salty liquid water. Further evidence comes from Europa's rotation. The outer ice crust seems to drift slightly, as if floating separately from the rocky mantle below. This would be impossible if the crust were solidly attached. Instead, it appears to glide atop a liquid layer, slowly rotating around the moon every 12,000 years. So what do we know about this ocean? Models suggest the icy shell is 15 to 25 kilometres thick. Beneath that lies water liquid despite the frigid surface. The ocean could be 60 to 150 kilometres deep, meaning Europa may hold twice as much water as all Earth's oceans combined. But water alone does not make a habitat. Life as we know it also requires energy and nutrients. Remarkably, Europa may provide both. Its ocean is thought to be in direct contact with the silicate mantle, just like Earth's seafloor. This opens the possibility of hydrothermal vents where heat and minerals rise from below. On Earth, such vents teem with life, entire ecosystems built without sunlight, powered only by chemistry and geothermal energy. If it can happen here, why not there? Europa is far from the sun, about 780 million kilometres away. Sunlight is 25 times fainter than on Earth, and the surface is frozen solid, averaging 160 degree arc at the equator and 220 degree arcs at the poles. Yet tidal heating from Jupiter's gravity may keep Europa's core warm, sustaining its ocean for billions of years. Imagine an alien ocean world, dark, vast, warmed from below, with black smoke vents releasing energy. Could microbes thrive there? Could something more complex evolve? We cannot yet say. But among all the worlds of the solar system, Europa stands as one of the most promising candidates for life beyond Earth. If life does exist beneath the ice, it would answer one of humanity's most profound questions. Are we alone? To unlock Europa's secrets, we need to go back. Fortunately, plans are already underway. NASA's Europa Clipper mission is set to launch soon, arriving by the end of this decade. It will perform more than 40 flybys, mapping Europa's surface in unprecedented detail, scanning for active plumes and probing the thickness of the ice. Instruments will search for signs of habitability and perhaps biosignatures. Meanwhile, the European Space Agency is preparing JUICE, the Jupiter Icy Moons Explorer. JUICE will explore Ganymede, Callisto, and Europa, giving us broader context for Jupiter's icy worlds. Like Clipper, it will study surface composition, magnetic interactions, and evidence of hidden oceans. Beyond these, NASA has proposed a Europa lander mission. Though still in planning, its goal would be to touch the surface sample ice and directly search for signs of life. Landing on such a hostile, irradiated world would be an engineering challenge, but the potential payoff is enormous. These missions hold the promise of discovery. Within our lifetimes, we may know whether Europa's ocean is just water or something alive. Europa is more than just another moon. It is a world with scars of stress, a surface of ice, an atmosphere born of radiation, and an ocean vast enough to dwarf our own. It is beautiful, hostile, and perhaps alive. If life can survive in Europa's dark ocean without sunlight beneath kilometres of ice, then life might be common throughout the universe. Perhaps every star hosts its own ocean worlds waiting to be discovered. As we await the next missions, let's reflect on what Europa represents, the hope that Earth is not unique, that life is not confined to one fragile planet. Instead, life may be a natural consequence of water, energy, and time. So when you look up at Jupiter through a telescope, remember its icy moon, Europa. It may hold the answer to the greatest question of all: are we alone? Thank you for watching Cosmic Compass. Until next time, let's keep reaching for the stars. You've been watching Cosmic Compass, where we explore the universe one story at a time. If you enjoyed this deep dive into Europa, don't forget to subscribe, like, and share. Your support helps us bring more cosmic journeys to life. Thank you to all of you who join us on these explorations. Together, let's keep asking the big questions, let's keep wondering, and above all, let's keep looking up. Until next time.